We are going to start important topics not only for academic purpose, it also is good to understand for practicals daily life in practical daily life. So circular motion of a car on a level road. This is our level road. This is our level road, and there is a circular path, but our ground is level. So a vehicle is, whenever a vehicle is turning at a level road, so the vehicle should have to minimize its speed. So how much the speed should be there at the level road? So this is the vehicle. Uh, Weight of the vehicles acting vertically downwards. This is mg. Now are the normal reactions. Whenever there is a object in a level surface, weight acting vertically downwards, to the weight of the object which placed on the ground, and the ground also acting in normal reaction, which is r. Since there is no motion in vertical direction, therefore r is equal to mg. Same way, the vehicle is uh, vehicle is putting on the ground, its weight is acting vertically downwards, normal reaction acting upward direction. So here therefore r is equal to mg. R is the normal reaction. So the ground acting in normal reactions with these tires and with these tires also. So we know that friction is friction is equal to mu into r. R is the normal reactions, F is the frictions, and mu the coefficient of friction. So here the first tire, there are two tires. F1 is acting inwards, and then outer tires also the force of friction acting inwards. So whenever the vehicle is turning at this turning point, its tendency is going in outward direction. Its tendency is getting in outward directions. Whenever the speed is increasing over a limit, if the vehicle crossing its speed to its limit, then there is outward direction of skidding of this vehicle. So the frictions is acting inward direction. Always frictions always acting in such a way that it overcome the relative motion between the objects. So that's why the vehicle is skidding outwards, now the friction acting inwards. So here there are two frictions. One is F1. The contact of the tire with the ground is acting in normal reactions by the ground on this tire, which is acting vertically downwards. Suppose this is R1, and same way the normal reactions by the ground on this outer tire is R2. So here R1 plus R2 is balancing the weight of this vehicle mg, and also we know that F1 is got by the relation number 2, F1 is equal to mu times of R1, and same way F2 is equal to mu times of R2. If I put these two values in equation number 3, so it will be mu times of R1 plus resultant frictional force mu times of R2. This is the resultant frictional force. Resultant friction which is acting inward direction. Now from the relation number 2, the relation number 2 says that the total friction is equal to mu times of r, and r is equal to mg, and total friction is equal to mu r1 plus mu r2. If I put all these values, so it will becomes mu is taken out, r1 plus r2 is equal to mu r, and we also know that r is equal to mg. Since the vehicle is turning in a circular path, if any object is moving in a circular path, there should be a centripetal force. The resultant of F1 and F2, which is acting toward the center of the circle, is acting as a centripetal. It provides a centripetal force. If the vehicles have velocity v, suppose the vehicles have the velocity v at a turning point, therefore the centripetal force will be mv square divided by r, since r is the radius of this circular path. Now the vehicles can only turning safely whenever this frictions, the resultant frictions should have greater than this centripetal force. So the equations become this ones. From here cancel out the value of m, and if you do like this, mu g, from here v square less or equal to mu r g. So the resultant frictions should have greater value of this centripetal force, at least equal to this one. From here, if I calculate the value mu rg, so from here maximum value of a vehicle which is overturning, which is turning as a circular path, should have square root of mu rg. So this is the maximum limit. So this square root of mu rg will be the maximum velocity if the cars not skidding, also not overturning at a turning point. So this should be the maximum velocity. If a vehicles crossing this limit, then the vehicles should have to go in greater circles, but we have no scope, we have no area to make a greater circle, greater path of this vehicle, so that the vehicles goes out of this road. So that's why this is the maximum limit for a vehicles to have a safe limit at a overturning point. Therefore, our maximum velocity of the vehicles at the turning will be mu rg. Here r is the radius of the circular path,